Hello and welcome back to the channel. My name is Jake Green. I'm the Head of Technical Engagement here at the Scolmore Group. And in today's video, we're going to be talking about EBBs and their functional testing and the way we need to have a look at them in terms of results and readings and regulations and all things EBBs. We've done lots of videos now. We're sort of moving on from what are they, what the locations do they go into, more about the testing and the requirements that are around that, Tim. So we've got regulations for you. We've also got images and diagrams of things that you will test. So we'll pop them up on the screen for you. But let's start right at the beginning.
Yeah.
Where does it say that we need to make sure that these EBBs are being looked after and what are the readings that we need to gain or test to?
So Jake, we're dealing with Group 1 and Group 2 locations.
Yep.
And Regulation 710.415.2.2 says in medical locations of Group 1 and Group 2, the resistance of the protective conductors between the earth terminal of any socket outlet or fixed equipment and any exposed conductive part and or extraneous conductive part shall be such that the voltage is given in 710.411.3.2.5 are not exceeded. And then it goes on to say, and you do this by ensuring that a maximum reading of 0.2 ohms exists.
Okay, so I'm just going to pick these two up for example.
Yeah.
So what we're saying then is between these 2 points here, these 2 terminals,
Even if they're on different circuits.
there cannot be any overage on 0.2 ohms.
That's right. So when you test between that point and that point, Jake, 0.2 ohm maximum.
Okay, and let's say then I'll pick this one up and I had this one, which is a POAG socket.
Yeah.
Again, from this point to that point,
Same rules
exactly
apply.
the same rules apply. Okay, so when we start to look at the initial verification of this, do these need to be recorded? And if they do, where do they need to be kept?
Yeah, well, there is a requirement in Regulation 710.641, which is peculiar because it sits outside of the normal Chapter 64, and of course, it's there where we expect to see all the testing requirements.
Yep.
But here it's very specific, and I think it's the only special location where additional tests are highlighted, I think, needs checking. But anyway, it does say in that regulation, measurements to verify that the resistance of the supplementary equipotential bonding is within the limits stipulated by the regulation we quoted before. So not only do you put in the equipotential bonding, you then have to confirm that the 0.2 ohm value is not exceeded.
Is there any specific tests that need to be carried out under HTMs, or is it just saying, right, HTMs refer back to this, make sure that you're following 7671 for all the testing requirements?
Generally, in terms of this testing, yes, it sits within 7671, but there is a reference, obviously, to HTM 0601, and you should reference it, free to download.
Yeah.
So there's no excuse, really, just to confirm that. But generally, what we're dealing with here is measuring and getting that 0.2 ohm value. You really should record it, although, strictly speaking, at the moment, the current certificate doesn't sort of lend itself too readily to that. So it may be, Jake, that you just record it on a separate sheet and you attach it to your EIC, so there's a record.
Now there would be a business opportunity for someone. Let's think then, when we move on from the initial verification, what happens a year on down the line?
You have to do it again.
Okay, and the reason that we have to do it again, is that because we're ensuring that it's still within that 0.2, or is there any specific other reasons for it?
Well, the fundamental reason for keeping it within that 0.2, remember, is to keep the maximum voltage down should a fault occur.
Yeah.
And because you're dealing with people who are inherently at risk, patients, you've got to go that extra step further in confirming that this is still good, because you're relying on that limitation of the voltage that appears under fault conditions to be constrained. And so we've got Regulation 710.651 that says it's measured annually to verify that it still is there.
If the readings sort of escape and they drop out sort of that 0.2, what's the sort of process to then go on above? Is it a complete rewire, or do we need to tighten connections, or we just need to ensure it's within that 0.2?
Yeah, you would need to do what's necessary to bring that value back down again. And it's likely to be loose connections, isn't it, when those values start rising? Or if somebody's maybe changed something or added a circuit and forgotten that they should extend that supplementary bonding to that additional point.
So just in terms of testers, we've got one here a nice mega there for us. But that's something simple, basic. Just do a low ohm resistance test.
Wandering lead test.
Wandering lead test.
Yeah.
So on the screen now, then you'll see the image that's been taken directly out of 7671. We've reconstructed it with some of our pretty nice products that you can see on the table here. So what we need to be doing then is we need to go from the EBB, from that EBB point, directly to the back of the socket outlets, the theatre lighting, the general lighting, the medical IT system, any gas points that may be connected, any sort of operating tables, all of those there. So we're going to go from the EBB with our wandering lead, going around all of the socket outlets and making sure that we are not escaping this 0.2 ohms.
And we're also, Jake, is again, as you said earlier, testing between different circuits. So again, that 0.2 ohm variance doesn't exist.
Is there anything else you want to add?
Just make sure you remind people there's an annual check to do.
Correct, yeah. Make sure that you're testing these annually. If you like the content that we provided you with today, make sure you like, subscribe and share, and we'll see you on the next one.